Hi, welcome to the Cyber Intelligence and Event Predictions in Cyberspace. This is the thesis proposal for the PhD program at the University of Évora. Now let's get started, shall we? Well, we will focus our talk in the cybersecurity realm. Even though we say cyberspace, we'll be focusing on the cybersecurity field. And we all know firewalls, anti-malware, and security security incident and event management systems, the CMs as you would call it. And these are very useful tools and frameworks. However, the CM will not give you a correct evaluation of what's going to happen. Sure, you may have the knowledge to answer a specific kind of attack, but will you know every single kind of attack that exists today? Maybe not. Maybe you see something new that you're not used to, but someone on the other part of the globe already experienced. And that knowledge could be used to help you if there is a way to share that information. Of course, we are not talking about sharing information, but actually predicting it. But how can we do that? Well, the CM does not actually predict information by itself. It does actually analyze the data that's being given to you. It may raise an alarm or two or several, considering your configuration, but it will not be enough. And that's where this thesis comes in. Well, we need to gather data, transform it into information, and from information we need to be able to develop what we call intelligence. And intelligence is something that we must have. Well, this is our definition onwards with this thesis. This is the definition that I'll be using throughout my work. And why? Well, we need to understand that information and intelligence are different things. Well, we need intelligence to understand what we can actually do with that information and what comes next. Of course, it's a very broad and big definition, but it actually summarizes the concepts of what we are trying to achieve. Of course, we need to understand the attack projection, the intentions of our attackers, and even predict what they are going to do. Of course, in order to do that, we need to also have our situational awareness. It actually was a term used in the military. But in cybersecurity, yes, there is cyber warfare, but that's not the topic that we're discussing here today. We are actually discussing our perception, comprehension, and the projection. It's something we actually need. But to have this information, we need a framework that actually represents the intelligence and the information we need to understand what we are actually seeing on the network or on a system. And one example of those frameworks is actually the STIX framework. STIX stands for Structured Threat Information Expression. It's actually a language and it's actually free to use, and we can adapt it into multiple programs and services, into multiple softwares. The framework can actually be developed in multiple languages, including Python. So, why am I actually doing a thesis? Am I doing a thesis on STIX? No, not exactly. STIX is just an example. STIX is just an example of a framework. My work will help people in the security realm to actually integrate what we know to be knowledge, the data information with event prediction algorithms, and gather what we have as an intelligence to help us make decisions, to help security professionals to actually do something about what we are actually seeing, what is going to happen, and what we can actually do. And of course, it's also used nowadays. Well, Stix is already being used on the market, and it's very well defined, and it will be the basis of my work. We will have multiple use cases in analyzing cyber threats and other scenarios. However, why should I choose Stick, and why this work is very important on that subject matter? Well, it does have a modular design, and that's the key factor to develop this thesis. Well, the modular design will allow us to integrate more modules as needed into this framework. Of course, the framework already exists. However, it does lack one key component. We'll get to that in a moment. Of course, those key elements that we already have do help a lot. Well, spoiler alert, we need to incorporate the time factor to the model. We need to integrate the event prediction algorithms into this module. Of course, the Stix framework already has multiple objects. The domain objects, like an attack pattern, it does have its own description. It does have the property names with their respective types. And of course, there is a description for each type and what we can actually represent. Of course, we also have relationship with other objects. Well, that's where the cyber intelligence comes in. However, it also, well, not however, but also it's very important to give this key information. It is represented in the JSON language, so we can actually store this information in a non-structured query language database. Of course, there are other models like the observables, the indicators, the campaigns, and the threat actors and vulnerabilities that do integrate with the MITRE framework, which is very useful. And there are tools and many other modules. Of course, not only the domain objects are used, but the relationships between them. However, let's get back to the point. It does lack one key component, and that's the event prediction algorithm, and we have a lot of them to work with. And that's the focus of this thesis. We can actually use an existing good framework, but we can integrate it and do multiple tests to see which framework, like a time series model or a gray model or something like an attack graph, which one will integrate correctly or present better results with the already existing framework. And we can actually use Bayesian networks, or let's say the Markov model, that does have a lot of information useful to any security professional. We can actually develop something that can be benchmarked to be used in the future. We are already trying to do that, and there is also the project Stix already exists, and we are actually trying to now develop and integrate the time factor, the event prediction algorithms into the framework, and that's the key component. And we are already trying to develop a time frame to this project to reach 3 years of development. Now, the end result will be a framework, but let me give you right now an interesting example of what we can actually do. The framework we are actually trying to develop will receive an information, will receive some kind of information from a security incident and event management system, or an IDS or IPS, and it will give information to something that we will call a parser. Now, this parser is very interesting. It can actually be used. However, we do need to have a database. That's our knowledge base with all the information. And not only that, we need to understand that this database can actually receive information from multiple inputs. Let's say something like the taxi framework. The taxi framework actually is developed on top of Styx, and other organizations can share their own knowledge, their own databases, giving us information about threat actors or campaigns or something like that. Of course, we are actually going to need to develop something in order to reach some kind of information. And that's the interesting part, because we will have an indicator parser, and this indicator parser will actually realize and confront some of the information that we are receiving from our CMs with the information we already have on our databases. However, that's not the key part. The key part, and the very interesting part of the project, is what comes next. And what is that? Just to finalize, we are actually going to use event predictions algorithms. So, event predictions. And when we say event predictions, we are going to test multiple algorithms in order to see which one will integrate with Styx the better, and to see which results are best. Let's see, we will have event predictions and, of course, our Styx framework. This could be any other framework, okay? It doesn't have to be specifically Styx. We can actually develop this architecture, and then when we are actually feeding the event prediction algorithms and Styx, what we are actually having is every single algorithm will be integrated with Styx, and we will analyze the results of the probabilities of an attack going one way or another, and we are actually seeing which results actually represent the best and most coherent results on the, let's say, the benchmark. So if I'm actually using Markov models, will I achieve a better result by actually using it with Styx, or should I use, let's say, an attack graph? These are the benchmarks we will actually do, and the end result will be a framework where we can actually integrate these event prediction algorithms with the cyber intelligence framework in order to achieve a very coherent and very useful result that will help every director, CTO, or CEO to actually answer correctly to a cyber threat. So, I thank you for watching, and if you have any questions, please feel free to contact me at any time.